with trig ratios, SOHCAHTOA, we always had a right angle triangle, but life doesn't work always in right angles. So what happens when our triangle doesn't have a right angle? And that's where we have the sine law and the cosine law. So we'll start with the sine law. Again, can be used for either finding side lengths or for finding angles. It's about identifying what information is given and what information is required. So we talked about using capital letters to represent an angle. So this B represents the angle B that's in here. Angle A is this angle that's made up between these two side lengths. And this space here considered angle C. To label the sides, we use the lowercase, and we use, I guess, what you would consider like the opposite rule from SOHCAHTOA, is from this angle all the way across, that side corresponds with it. So this is side C. From angle A all the way across is going to be side A, and from angle B all the way across is going to be side B. Using the formula. So again, it comes down to looking at the triangle, what's given, which part of my formula can I substitute values into the variables, and which ones are left unknown. So first thing we're going to do is label our triangle. And again, it doesn't matter where your ABCs are, but as long as your angle and your sides correspond with each other. So I'm going to say this is angle A, angle B, angle C, which makes this side B that's unknown and we want to solve for. This is side A, we don't have any information for. And side C, we do have the length of it, of 7 kilometers. And we have all 3 angles, remembering that all angles in a triangle add up to 180 degrees. So that would help us if we needed to find an extra angle. So I would write my formula out first. I only need 2 of the corresponding parts. So since I know that I have both the information for C and my unknown is a B, those are the 2 pieces that I'm going to use. So again, my first step is labeling my triangle. Second step is writing my formula. Third step is substituting in the values for the variables. I'm going to try and write another color so it doesn't squish. So we have B is unknown, but the angle B is 105 degrees. C is 7. And sine angle C is 35. So that's step 1 is labeling, step 2 is the formula, step 3 is substituting in values, step 4, isolating the variable. We want to get the variable by itself by doing opposite actions. So right now B is being divided by sine 100, so we're going to multiply both sides by sine 105. That's getting squishy. We're going to multiply both by, and that's going to cancel out here. So B right now equals sine 35. And like last time, it's really important to know your calculator and how the order of operations go. And you want to make sure that on your calculator the division of 7 and 35 and sine 35 is happening and creating its own value before we're multiplying by sine 105, so that your calculator is not mistaken what you're entering and not multiplying or dividing other values with each other. Easiest way to make sure that your calculator is being programmed right by you is to do it separately. So 7 divided by sine 35 is 12.2, and sine 105 is 0.96, and then we multiply those two together and we get 11.78. Somebody else might get a little bit higher or lower of their decimals due to how many decimals you carry forward, or if you're able to do it all in one step on your calculator. I believe, just trying it now, times So on my calculator, when I did it all in one step, so it's carrying all those extra decimals, I got 11.788. So fractions higher. This time, what if we wanted to solve for an angle? So again, first step being that we are going to label our triangle, and we'll go A, B, C, and this is opposite of angle A, so side A, side B, and side C. We're going to solve for angle C. So angle C's are unknown. Our two, what I'll call matching, corresponding angle and side is given, and our unknown, angle C, has a given side. So we know that these two corresponding pairs will work in our formulas. So this time, because we're solving for the angle, it will be easier to write the ratio on top. So sine A equals sine B. So 1 was labeling, 2 was the formula, 3 is substituting in values. So, and not sine A. We have B and C. So sine C is unknown, that's our variable that's staying. Side length C is 4.7. Sine B is 63 degrees. And side length is 5.5. Now it comes down to number 4, isolating the variable, getting sine C by itself. So we need to get rid of the denominator of 4.7. We're going to multiply both sides, opposite operations. So multiply both sides by 4.7. So we have sine C equals sine 63 divided by 5.5, and again the brackets help for organization, times by 4.7. Now, just like in SOHCAHTOA, when we had to find for angles, we had to use our inverse operations. So I'm first going to find 63 sine divided by 5.5, and that's 0.162 times 4.7. Times 4.7, and that's decimal 7614. You can keep 3 decimals, 4 decimals. The more decimals, the more accurate it'll be. So at this point, to be able to solve for C, I have no room underneath, but you would keep going underneath. C is equal to the inverse sine of 0.714, or 7614. So again, on your calculator, using the inverse, and you get that angle C is equal to 49.58, so 49.6 degrees. So then I can label it there. If they then asked for what is angle A, you could do those calculations again, or you could use the sum of a triangle rule. The sum of a triangle rule where they all must equal 180 degrees.